All right, hello everyone. Welcome, welcome. Happy Monday. I hope everybody had a nice, restful, relaxing weekend. As I'm sure you are, at least I hope you're aware, we have an exam coming up in class this week. But before we talk about all that, I actually kind of wanted to shift over and chat with you about the schedule a little bit. Because of the exam, there are some things that are different about this week compared to how the class normally runs. The big thing is that on Wednesday in your lab section, there is no studio this week because of the exam. Yeah, there will be no in-class exercise. However, you do have an assignment that is due on Wednesday in your lab section. And so I want to make sure everybody is aware that while there is no studio and you don't have any group activity to work on, the TAs will be there in the labs on Wednesday for you to submit your assignment. And also to answer questions about the upcoming exam if you want to talk to the TAs about exam questions. So please come on in on Wednesday if you would like to do either one of those things. Also, just kind of want to remind you that you can turn in the assignment early in office hours if you want to. And I mean, if you turn in the assignment early and you don't have any exam questions, maybe I won't see you on Wednesday. That's a decision for you to make. There is no studio. We won't be taking attendance. So unless you want to turn in your assignment or have exam questions, it's up to you to decide how to use that time, right? I'm not going to tell you you have to be there. You don't have to be there if you have all your other stuff under control. But if you have exam questions or need to submit your assignments, then yeah, come on in. We'll be there on Wednesday to help you out with whatever you need help with. Are there any questions before we shift and talk about the exam? Are there any questions about the schedule for this week or logistics, anything like that? Want to make sure everybody knows what's happening this week. All right, fantastic. Then let's chat about this exam. I'm going to spend just the first 5 or 10 minutes or so just kind of going over some of the general logistics, making sure everybody knows what to expect. And then hopefully we'll spend a good portion of the time today working through some review problems and talking about code. But first, let's talk about logistics. The exam is this Thursday from 6:30 to 8:30 p.m. The topics that are going to be covered is pretty easy at this point. It's everything that we've done so far. So modules 1, 2, and 3. Anything we talked about so far is fair game for this exam. What should you bring? You definitely need to bring your ID card. So please make sure you have that on hand. Some pencils. Some people like doing the exam in pen. That's your choice, I guess. I think pencils are probably the better pick. And then also, you're allowed to bring one sheet of paper with you that has notes on it. I get a lot of questions about this, so I kind of want to clear up some things about it. It is a regular size sheet of paper. And what I mean by that is a sheet of printer paper, a sheet of notebook paper, either of those will do. I am not going to walk around with a ruler and measure your papers and make sure they have the exact dimensions or anything like that. If it is a regular size of paper, then you're fine. If you walk into the exam with a sheet of paper that's the size of this desk, then we're going to have a conversation about that, right? But if it's just a regular size sheet of notebook paper or printer paper, then no issues with that. You can put notes on both sides. So you can write on both sides of the sheet of paper. You can do it handwritten. You can do it typed. That is up to you. I don't care either way. The one rule that I have about the content of your sheet of paper is that if I am walking up and down the aisles before the exam starts, which is exactly what I will be doing, if I look at your sheet of paper, pick it up and look at it, I should be able to tell what's on there. I should be able to read the contents of your sheet of paper without needing 3D glasses or a microscope or some fancy piece of equipment, right? So don't try and do anything weird. Just use regular fonts. I know people like to shrink the font down and make it so they can cram as much stuff on there as possible. I mean, as long as I can still read it, right? I have 20/20 vision, so as long as I can still read it, that's totally fair game. I don't have any issues with that. And then as far as other rules regarding the exam, I get often asked if students can bring a calculator on the exam. You are not allowed to use electronic devices of any kind, including calculators. You do not need a calculator on the exam. You will not be allowed to use a calculator on the exam. While it is true that there may be a little bit of math on the exam, all of the math has been written in such a way as to be doable either in your head or, worst case, maybe a little bit of off in the margins of the exam. I am not going to ask you to do weird arithmetic on the exam. You're not going to have to compute square roots in your head or any weird things like that on the exam. That's not, I mean, maybe the square root of 4, right? But like other than simple examples like that, you're not going to be expected to do weird math. You do not need a calculator, and you won't be allowed to use one, so leave your calculators at home. As far as where to take the exam, if you have accommodations, then hopefully you've already talked to disability resources about that and set up time to take the exam with them. For everybody else, the exam location is based on the last 3 digits of your ID number, and I just posted this list this morning, so please be sure to take a moment and figure out exactly which exam room you're supposed to be going to. There are 3 rooms in which this exam will be taking place. I would also recommend that if you haven't been to this room before that you're supposed to be going to, that you figure out where it is ahead of time. I definitely have quite literally had students emailing me at like 6:28 p.m. asking me where their exam room is. I can tell you right now, I'm going to be a little busy at that time. I'm probably not going to be looking at my email at 6:28 p.m. on the day of the exam. So please take a minute, locate your exam ahead of time. Make sure you know where you're going before Thursday so that you aren't scrambling around trying to figure out where you're supposed to go after the exam has already started. A couple other quick notes about what to expect on the exam. I mentioned that it's going to cover modules 1, 2, and 3. I also gave you a whole boatload of material to use to study. So I want to make sure everybody is aware that I posted the practice quiz, this big long practice quiz, as well as this coding repository. So the practice quiz has multiple choice and fill in the blank style questions, whereas the coding repository is going to have code reading and code writing style questions. All of the questions have been on past exams. In fact, the quizzes that you've been taking come from this pool of questions. So you've been studying for the exams already by taking the quizzes. That's somewhat intentional. You've already seen some past exam 1 questions. One question that I get a lot is how many multiple choice questions are going to be on this thing? How many fill in the blank? How many code writing? For starters, I'm not done writing the exam yet, so I literally don't know. Could not tell you even if I wanted to, but I also don't really want to. I certainly understand the anxiety around exams, especially the anxiety around uncertainty, right? Kind of what's going to be on it, but you don't know everything that's going to be on it. I mean, that's just life, right? I'm sure you would feel better knowing exactly how many questions of each type are on the exam, but I really don't think that should or would have an effect on your ability on the exam or studying for the exam. You're not being tested on your knowledge of multiple choice questions. You're being tested on your knowledge of computer science. And I can tell you from experience and all the tech interviews and places I've been, not once has anybody asked me how many multiple choice questions did you get right on your first computer science exam. That's not happened, right? So I get the anxiety. I want to make it very clear. I also have had exams that make me very nervous. People get nervous about comp sci exams. I understand completely, totally. I'm trying to make the argument that if you know the concepts well, it doesn't matter if it's a multiple choice, fill in the blank, code write. It doesn't matter what kind of question it is. Maybe seems a little obvious, but I'm not afraid of any comp sci question that you could ask me over these topics, regardless of the format, because I feel like I know the concepts. And that's kind of where I want you to get to. I understand you're just learning. I've been doing this for years. You've been doing it for a few weeks, so not quite the same thing, but please try not to focus on the format so much as the concepts, and I promise you it'll work out. As far as, and one other a point I like to make about the exams, especially on the code reading, code writing problems. Not so much the multiple choice fill in the blank, but on the bigger problems that ask you to write some code, there is partial credit available. So multiple choice fill in the blanks, usually all or nothing. They're not worth as many points as the larger code writing problems are. But even if you don't know an answer for the code writing problems, I would beg you, plead with you to please put something down on the sheet of paper. If you leave an answer blank, I quite literally don't have any other option but to give you a 0 on that problem. I don't want to do that. I want to give you as much credit as possible. So give me something that I can use to give you credit, even if you don't know the full answer. Put down what you do know. Even if you can't write it out in code, write it in English. Tell me what you would do in English. Will you get full credit for that? No, but I'll give you a few points if you can describe in English your thought process and it's along the right lines. I'll happily give you some partial credit for that kind of stuff, right? So try and be smart about it. Try and get down as much as you can about these answers. I think that is about it in terms of my little speech about stuff upcoming on the exam. Before we switch over and do some review problems, does anybody have any questions about where to go, what to bring, stuff like that? Yeah, in the back.
Yeah, how would it work with like handwriting the code and format? Like, are there gonna be blanks with put this thing inside these brackets, or is it just gonna be like a blank sheet and it tells you to write this thing?
I mean, it's going to be, I usually put lines on the paper so that you have a place to put stuff. It'll never be unclear as to where you're supposed to write something. But I mean, for the code writing questions, yeah, it's very open-ended. The examples that I posted and we're hopefully about to see show you exactly how open-ended they are. Yeah, I hope that answers your question. Yeah. Any other questions I can address about exam logistics before we hop into taking a look at some review problems? I want to make sure everybody knows what to expect. Okay, great. Then for the remaining amount of time, we have an hour and change left with which to talk about computer science. I want to go through as many review problems as possible with the time that's left. I am happy to talk about multiple choice fill in the blank questions from the practice quiz if you want to. Last section, the one that we did right before this, they wanted me to do code writing problems the whole time, and that's fine too, right? I would very much like to do problems that you are interested in, so I'm going to open up the floor and take suggestions for problems that you would like to see me work through, talk about, and if nobody has any suggestions, I'll just start pulling some at random and doing it. But if anybody has a problem from any source that we've talked about in this class that you would like to see me go through, I would love to hear about it. Anybody have a practice problem they'd like to see me go through? Any takers? Got a couple ideas. If not seeing anybody jump out, that's fine. Let's go ahead and do some practice problems, starting with yeah, I like this one. This very last one, question 14 of the code writing. It's an array problem. I bet we'll probably do a few different array problems today. If I had to guess, that is often the topic that I get asked about during the Exam 1 review session. Let's start out with a one-dimensional array problem, at least for the first one for the day. We want to create a mirrored array. So if I give you an array that contains these values, I want you to give me back an array that is twice as long, right? And contains the first three values in their original, or all of the values in their original spot, and then reversed as well. So whatever array you start with, I'm going to end up with one twice as long, and the values will appear forwards and then reversed. So I want to create an array that contains its own mirror, basically, and it's going to mirror at the halfway point. When working on problems like this, a lot of times you're going to see, especially with arrays, you're going to see this statement included as part of the problem specification. It's going to say your code should work regardless of the size of the array or the values that it contains. So what I mean by that is, down here I've given you an example array to work with, and it looks exactly like this. On the exam, however, it's not going to look like this. On the exam, if I gave you this problem, or actually the way this problem was given in the past, oh, not like that, is going to look something like this, where I just have 3 dots in there, basically saying, you know, there are some numbers here, there are some values here, but I'm not telling you what they are, I'm not telling you how many they are. What I'm telling you is it doesn't matter what they are or how many they are. You should be able to write code that works regardless of how many numbers there are or what those values are. And when you're studying, I think it's important that, you know, while, yes, it's nice to run it through with an actual example, make sure that it works, it's also important, I think, to change the example and run it again and make sure the code still works. And do that a few times to make sure that your code is still going to operate regardless of you know, the size of this array or the contents of this array. For starters, you know, to kind of explain a little bit more in detail about what I mean by that, let's start working on this problem. We can see that if I start with, you know, 3 values, I should have twice as many at the end. So I need to create that array that is twice as big. That's, I think, step number 1 is creating my array that's twice as large. It's going to be an integer array. And we have to give it a name. I'd probably call it something like mirror, because that's what we're doing. We're creating mirrored arrays. What comes after the equal sign? If I want to make an empty array of integers, what do I type next? Starts with an N? New, there we go. New int. And then I have to put something in these brackets, right? I have to say how big I want this array to be. Now be careful, I could say 6 here. And for the example that I've given you, that's correct, right? But that won't be correct for every array. This would lose points. This would lose points on the exam. It's correct only for this very specific, only for arrays of length 3. I want this to work for an array regardless of its size. So with that in mind, right, it is always, always, always more appropriate to ask the array how big it is by saying data.length. And if I want an array that is twice as large, well then I will multiply that by 2. Okay? This is a better way of doing it because if I change the size of this array by adding and removing values, this is automatically going to detect that and give me the appropriate sized array, right? We'll actually test that out in a little bit once we finish up this problem. But for now, we need to actually, you know, put these values in. And notice that for each value in my original array, it's going to show up twice, right? It's going to show up twice. There's a few different ways you can approach this. I saw actually a lot of different paths. Some people did a loop for the first half and then another loop for the second half. You actually don't need 2 loops. You can actually do it all in 1 loop. But I would accept either one. I want to make it clear that, you know, just because there are different paths to get there doesn't mean I'm looking for a specific answer. Any answer that gets to the destination is good. So I'm going to write a loop that goes through once, and I want to visit each of these values 1 time. In fact, we have a name for that. That's called a traversal, an array traversal. So I'm going to write the standard quote loop for an array traversal, which I showed in class just last week, I believe, where I say I is less than data.length, I plus plus. Oops, I forgot to name my variable here. There we go. Forgot a letter. Now I want to extract each value out once, and I want to put it into my destination array twice. So let's think about that for a second. The first one I think is easy. The first position is simple. If I deleted my example array up here. Whoops, I didn't mean to do that. If I pull this out of position 0, it's also going to go into position 0 of my destination. That's the easy one, right? So if I say mirror at 0 is equal to data at 0, actually, I'm sorry, it shouldn't be 0, it should be I. I don't know why I put 0 there. mirror at I is equal to data at I, that takes care of the first half. Is everybody with me on that? Everybody see how that accomplishes the first half of the array? So now we just have to figure out the second half of the array, and I think that's going to take a little bit of arithmetic, because where it goes over here depends on how big the array is, right? I know I'm at the 0 position here, and this is position, not 6, right? It's 5. Yeah, it's 5 because the length is 6. The last position is 1 less than that. Okay, so this is going from 0 to 5. This is going from 1 to 4. And this is going from 2 to 3. There's a pattern there. There's definitely a pattern there, right? The length of the array minus my original position minus 1. To indicate the fact that I need to not go off the edge of the array. Or in other words, the way I would say that is mirror at mirror.length minus I minus 1 is equal to data at I. Think about it for a second. The length here is 6. So if I'm doing the very first value, position 0, 6 minus 0 is still 6. Minus 1 gets me 5, meaning I would put the 1 in at position 5. That's what I want. If I'm looking at this value, the 2, that's at position 1. So 6 minus 1 gets me 5. Minus 1 more gets me 4. And that's going to put the 2 in this position right here. And so on and so forth for the entire contents of the array. And I think that's it. I think in terms of what this problem asked for, this is it. This is the answer. This is the solution. This is where I start to see some people looking a little bit surprised / confused, but I think there's an important point here, right? I'm not going to try and ask you questions on this exam that require pages and pages and pages and pages and pages of code. That's a time waster, and also it's just not necessary for you to convince me that you understand what's going on. This is a pretty short answer, 4 or 5 lines. I would say that's pretty typical. There might be some that are a little bit longer than this, right? But think about what you can do with that information. If you find yourself staring at a problem on the exam and you're like, I think I know the answer, but it's going to take like 50 lines of code for me to get there. Can you do it that way? Yes. Is it possible that your answer is correct and you'll get full credit for it? Also yes. Are you overcomplicating the problem? Also probably yes, right? And also keep in mind, the more code that you write, the more opportunities there are for you to make mistakes in that code. So really, it is in your best interest to try and keep your answer as concise as possible while still doing enough to accomplish the task at hand. You can put that 50-line answer down on your paper if you want to. We'll grade it, and we'll try to give you as much credit for it as possible, but there's almost always going to be an answer that is short and sweet and to the point like this. Not almost always, always. I write the exam questions with this in mind. I definitely have a solution in my head that is going to be, very direct and to the point. So keep that in mind. It's up to you, whether it's worthwhile to try your very long answer or not, or try and come up with a shorter, more simple answer. Another thing to keep in mind is that while, I'm telling you that this is a solution, and I think that it is going to work just fine, if I run this, I'm going to see nothing. There's no print statements. I didn't ask you to print anything. Nowhere in this problem description. In fact, it says the opposite. It says it is not necessary to print the result. I didn't ask you to print anything. So on the exam, oftentimes I'm not worried about that so much. Don't worry about it. But if you're studying, you probably want to know, right? Is this correct? How do I know if this code works properly? So in that case, you might want to add some stuff to print out the contents of the array and make sure that it's working properly. So let's do that. I'm going to add another loop down here. This is not required as part of the answer, but I want to make sure that my code is working properly. So I'm going to print out the contents of my mirrored array and then run my code a couple times and make sure that it's doing things in the way that I would expect. So okay, here we go. For the example that was given, 1, 2, 3, 3, 2, 1, that's good. But as I was talking about before, we should be able to come up here and change this. So if I add some more numbers on, like a bunch of 5s, actually maybe I don't want to make them all the same because that'll be hard for us to verify the answer. 10, 11, 12, right? I'll add a few more values on here, run the code again. It should still work. It should still work. 1, 2, 3, 10, 11, 12, 12, 11, 10, 3, 2, 1. Yeah. Yeah. It's there. It's working. So I'm pretty confident that this is a good solution to this problem. Any questions about this problem, how I got there, any of the code that I wrote? Before I move on to take a look at another one? Anybody ready to shout out an example for me, or should I pick another one for myself? Yeah.
Sorry, I have a question about.
Yeah, please, please.
I'm a little confused with exactly how the last line of the loop works.
This one right here?
Yeah, that one.
Tell you what, instead of explaining it to you, why don't we run it through the debugger? Will you be able to do this on the exam? No, but when you're studying, I think it's a very valuable thing to be able to do. I would encourage you to please run examples through the debugger whenever you're stuck or not quite sure how they're working. So I set my breakpoint right here on line 33. Let's walk through this one step at a time and see if we can do a better job of understanding what this loop is doing. Here's our original array, and then here's our mirrored array over here. You can see it's starting out as it's starting empty, all zeros, right? It is twice as long though, so far so good. I'm copying each value twice. So the first value is just copying it to its original position. And after I run that line, you'll see, okay, the 1 got copied there. I also want to copy this 1 to the very end. So how do I get from 0 to 11? I'm taking the length of this, which is 12. I'm subtracting the original position, which is 0. And then I'm subtracting 1 more from that, which should get me to 11. This one, by the way, is to account for the fact that if I have an array of length 12, the address of the last one is 11. That's why the -1 is there, right? That's why the -1 is there. Otherwise, this, I would say, is doing the actual mirroring. Subtracting I from the length of the array is what's performing the mirroring. And we just have this extra term of -1 to account for the fact that we start from 0 instead. And so when I run this, I'll see that the 1 gets copied to the end of the array there, right? And we can see that for all the values. So for the next value, the 2, it's going to put it, of course, in the front of the array first. But then, okay, 12 minus 1 is going to be 11, minus another 1 is going to be 10, so the 2 is going to end up at position 10. And so on and so forth. For the 3, it gets copied into position 2, but then also position 9. And actually, I mean, one of the reasons I put this on the exam, this is maybe a little hint for you if you have not started or are currently working on the 3rd homework assignment. This is going to show up on the 3rd homework assignment. That's part of the reason why I put this problem on the exam. It's because similar concepts appear as part of the 3rd homework assignment as well. So you might want to take note of that if you are not done with assignment 3 yet. This little statement could come in handy for you. But yeah, hopefully that debugger, and of course you can finish stepping through and notice that the last values that it's going to put in are the ones in the very middle. And then it prints it out. Any other questions on this problem before we take a look at some different review problems? Yeah, please.
I was wondering, why is there another for loop above the print?
I'm sorry?
Like, why is there another line
This loop here?
Yeah.
So the alternative would be to do what? I want to see the contents of this array. How would I do that without the for loop? I think this is something we actually talked about in class last week, and maybe is useful to go watch the video and take a look at if you need a refresher. I cannot just print out an array like this. That's not going to work. I showed you this last week. If you do, you're going to see something that is, oops, I'm still in the debugger. I didn't mean to do that. Let me switch out of debug mode. If you do try to print out the entire array directly, you're going to see something like this. I talked to people in the studio about this. It's in the video from last week. Definitely go back and refresh your memory on that one if you need to. In order to print out the contents of an array, we need a loop. We have to traverse the array and print out each element one at a time. Any other questions about this problem before we move on to another one? Does anybody have any suggestions for a problem for me yet? Or should I pick out another one? I'm probably going to do a 2D array one next, unless anybody has another. I see people nodding their heads. Okay. Seems like a popular option. Let me see if I can pick one out here. Do I want to do that one? No, that's not a 2D array. Let's do this one. Question 12. Question 12 wants us to compute the sums of all columns of a given two-dimensional array. So if I give you this two-dimensional array, I want you to create a one-dimensional array that contains the sums of all of the columns. So the 1 plus the 4 gets me this 5. The 2 plus the 5 gets me this 7, and so on and so forth, right? That's our task for this particular problem. And it's the same story as last time. I gave you this array as an example, but you should definitely try adding some rows, adding some columns, and changing the array. Make sure your code still works, regardless of how big this array is or what it contains. But let's go ahead and start writing this out. I think the first step is to create this array. Create the array that's going to hold my sums. So, okay. I want to create an array to hold my sums. It's only one-dimensional. You can see that very clearly here. It's a one-dimensional array, so that's why I only have this pair of brackets here. What am I going to use for the size, though? That's kind of the first little tricky part. I want this array to have one entry for each of the columns of my two-dimensional array. But just like last time, I don't just want to type in 3. That's not going to work. That would lose points. I want to ask this array how many columns it has. How many columns do you have? Does anybody remember how to do that? How do I ask the data array how many columns it has? This is something I see on the sheet of notes, like on almost everybody's coming into the exam. Definitely a good one to put on there if you can't remember it off the top of your head. Yeah, go ahead. So data dot length is very close, but not quite right. What does data dot length tell me? The number of rows? This is the number of rows. There you go. I want the number of columns, not the number of rows. I want this array to have one entry for each column. So in order to have it pull the number of columns, I say data at 0 dot length is how I would read that. And again, to remind you of how this statement is working or how to think about it, I'm grabbing row 0 and taking the length of that row. The length of a row tells me how many columns there are, right? So that's how that statement is working. But this will go ahead and create my one-dimensional array that has one entry for each column. And now we need to do the work. We need to actually perform the sum. And so ask yourself, right? Do I need to visit each one of these values? If the answer is yes, which I think it is, right? I do need to look at every single value in the array, in this two-dimensional array. Then I want to see those red lights flashing in your brain and say, oh, I'm doing a 2D array traversal. Professor Shook said that with a 2D array traversal, I don't need just one loop, I need two. I need two loops. And in fact, though, I need to use that nested loop structure. Another good thing to put down on your sheet of notes, if you need to, whenever I'm doing a 2D array traversal, it's going to look something like this, where I is going to go, typically I do the rows first, and then the columns. You can actually do it the other way if you want to. It's a little bit unusual, but can work. Can work if you want to do the columns first instead of the rows. But I'm going to have I represent the row that I'm on. And I know that because I'm using data.length here, the number of rows. I might even leave a little comment to myself to remind myself this loop represents the rows. And then for the nested loop that goes in here, my value of j is going to represent the column that I'm on. Okay? We're actually almost done with this problem, believe it or not. I need to extract each of these values out and then just add it into this array, one at a time. So for extracting that value out, remember it's a 2D array, so I need two indices, a row and a column. So data at ij is going to get added into my sums array. So I'd probably say something like this. Notice I used plus equals here. So I'm taking this value out and I'm adding it to whatever is in my sums array. But I intentionally left this blank. We got to put something in there, and this is maybe the last tricky part of this problem. What's going in there? Pretty good guess it's probably either I or j, but which one is it? Is it I or j? What does I represent? What does j represent? I represents the rows, j represents the columns. My sums array is keeping track of the sums of the columns. So I want j, since j represents the columns. I think this is it. I think that's the solution to this one. There are others. This is not the only solution. If you give me a different answer that gets me the same place, then good for you. Happy about that. That is 100% a-okay. But this is how I think about the problem. This is, I think, a very simple, direct way to get to the solution. Just like the previous problem, it would be nice to verify if it's correct or not, right? I didn't ask you to print the array out, but if I want to print the array out and verify that it's correct, that is certainly something that we can do. Sums at I. So I'll just print out the entire sums array after I'm done and make sure that it works properly. For this example here, I should get exactly this. Should get exactly 579. Let's give it a shot. There's my 579. But as I mentioned before, grab one of these rows and oh look, now it's got 3 rows, and I should be able to run this again and it should still work. The numbers will be different, obviously, because there's more numbers now. But if I run it with these 3 rows, do I still get the proper sums back out? I hope so. 9, 12, and 15. So 1 plus 4 plus 4, that's 9. 2 plus 5 plus 5 is 15. Yeah, it works. It still works. And if I take rows away, or if I add columns, or take columns away, I think this code would still work. I think that's important. One other thing that's kind of important about this one, this line right here, can kind of confuse people. I'm taking advantage of the fact that when I create this array, I say it's empty, but it actually has zeros in it, right? So the first time that I add something to it, I'm adding it to 0, which ends up not hurting anything. This is another one that I think is very, 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 very useful to go through the debugger. I'd actually like to take a minute or two and walk this one through the debugger with you as well. So I set my breakpoint right here on line 35. I'll run through the debug. Over in my variables window, we can see that my sums array starts out as all blanks, right? All zeros. And here's my data array with its 3 rows and 3 columns. And as I step through, it's going to grab, first it's going to grab the value at 0, 0. There's my I and j. So the value of 0, 0 is 1. It's going to extract that out and put it in the sums array at 0, since that's what j is. So after I step, you'll see, oh, there's the 1. And then it'll do the same thing for the rest of the first row. So there's the 2 and there's the 3. Right? So after I've gone through the first row, my sums array looks exactly like my first row. That's not surprising. But as I go through the second row, we'll see that, okay, this time I'm going to add 4 to the 1. So the next value that gets, the next value that the code takes care of is at position 1, 0. So it's going to take this 4 and it's going to add it to the 1 at position 0 to get 5. And it'll do that for the second row. And then finally, I'll do it one more time for the third row. And that's my answer. We can actually see this is the same answer that got printed out when I ran it a moment ago. Okay, let me stop this and switch out of debug mode. The quote-unquote official answer is this one right here. Don't need to do the printing. Are there any questions or any other things you'd like to talk about regarding this problem before we move on to another one? Alrighty. What's next? Are you picking or am I picking? Anybody got one for me yet? You want me to keep picking? I'm happy to do it, I suppose. Kind of want to go through another 2D array one, but it's different. It's not kind of similar, but kind of different. I think I'm going to do this one next. Question 4. So this one's a little bit different than the last one that we did. I'm given this 2-dimensional array, and this time what I want to do is I'm going to perform what's called a sample. So I'm saying I want to randomly select n values out of this 2-dimensional array. So if n is 3, right, I want to randomly, maybe I'll randomly pick the 2, and then maybe next time I'll pick the 4, and then maybe for my third number I might pick the 2 again, right? There's nothing to stop me necessarily from picking the same random number more than once. But I want to, pick those 3 random values, and then this time I was even a little bit generous, and I gave you a line of code to make a one-dimensional array. I want to randomly pick values out of this 2-dimensional array and take the values that I randomly selected and put them into this 1D array. For those of you who've done any kind of sampling before, what I'm doing is a random sampling with replacement. I'm able to pick the same random value more than once, so we call that with replacement. Now, you might be thinking, 2D array. We have that nested for loop structure that works really well with 2D arrays. And that's true. I want you to think about that. I want you to, evaluate the possibility that the nested for loop structure is the right one to use for a problem that deals with 2D arrays. However, keep in mind what that nested for loop structure is for. I use that when I want to visit every single position in a 2-dimensional array. Do I need to visit every single position in this 2-dimensional array? I do not. I do not. In fact, I'm kind of intentionally not doing that. I'm picking values from at random out of this 2-dimensional array. So what I really need to repeat is that random selection. I'm not going to visit each one of these values in my 2-dimensional array. I'm going to make a loop that goes n times, right? And within that loop, I will randomly select values out of that two-dimensional array. So even though I'm using a two-dimensional array as part of this problem, we don't need the nested for loops for this problem. Sometimes you will. I would actually argue probably more often than not, if you're using two-dimensional arrays, that nested for loop structure is probably going to come into play, but you have to answer the problem as it's written. Be careful what the problem is asking you to do. The repetitions here are really based on n. Not the number of rows and columns of my two-dimensional array, but n. I need n repetitions. I can do that with one loop. I don't need two loops to perform n repetitions. So let's go ahead and do that. I'm going to say for int I is equal to 0, I is less than n, I plus plus. Now I need to do my random selection. But notice that if I want to pick this 3, for example, I need to go to that position. And in order to go to that position, I need two indices, two values. I need a row and a column. So I need to randomly generate both of those values. I need to randomly generate a row, and I need to randomly generate a column. Furthermore, I need to do so in such a way that I pick proper row numbers and proper column numbers. I don't want to pick, row number 7. There is no row number 7, right? I need to make sure the random numbers that I'm generating are the appropriate size for the given two-dimensional array. So, okay, let's talk about that. Starting with the row, we know math.random's coming into play, right? Math.random gives me a value between 0 and 1. That's definitely not what we want. The 0 actually, though, kind of works, right? 0 is a good index. But I need to be able to, scale this up so that I can select any row from the array. And the way that we talked about this is by using some arithmetic to scale our random values. So in particular, right, if I have 2 rows, I want to scale it up by 2. But I don't want to put 2 here. I actually want to be a little bit more careful about that. I want to ask how many rows there are. We've already talked about how to do that. So I'm going to multiply by data.length. Let's do a quick little sanity check on this and see where we're at, right? If this gives me 0, then 0 times, whatever length is still 0. And that's okay. I like 0. 0 is my first index. So 0 is an okay result. If this is, remember, it can't be 1. So it can only be 0.99999 repeating. So if this is 0.99999 repeating, and I multiply that by the number of rows, which in this case is 2, then I would get 1.99999 repeating. Okay, so let's pay attention to the fact that I can't use decimal values as an index to an array, right? I got to get rid of that decimal value. I kind of already hinted at that right here by saying that I'm making an integer. What's it called when I want to change the type of a value from one type to another? Casting. Good. We need a cast here. We need a cast. So in order to cast this to an int, I'll stick the cast out front to an int. I'm making the claim now that this will work. This will generate a valid row number between 0 and the number of rows, just like I want. If I have, in this example, I have 2 rows, right? So I'm saying that the only values I would get out of this particular example are 0 and 1. That's it. 2 is not an acceptable value, right? Because that would be on the edge of the array. If I have 10 rows, I'm making the claim that this is still going to work, and it's going to give me all the possible indices from 0 to 9, because I am multiplying it by the total number of rows. So it's going to scale up by that amount. And we're going to have a very similar looking statement for the number of columns. So down here, I'll make another variable called column. And instead of multiplying by the rows, I'll obviously multiply by the number of columns. And I've got the same general thing happening. This will get me a valid column number, column index. And now all I have to do is use this row and column to extract my selected value out and stick it into the one-dimensional array. So I'll say points at, what am I going to put in these brackets? Am I going to put row or column? Might be a little bit more helpful if I come up here and instead of saying n, I say points.length, which is n. There, it's the same, right? Does that help you decide what to put inside the brackets here? Hopefully. I am generating n random values. I'm generating one random value for each entry in my array. I will extract that value out of my data array using the random row and column that I generated. This is it. Actually, I gave you that first line, so really the solution is this. This is the solution. This is it. I don't think we need anything else. I don't think we need to do anything else. I do think there is a mistake, though. Does anybody see? Well, let me print out the contents of our points array, and then maybe it'll be a little easier to figure out where our mistake is. Let's make sure it's actually working. By just printing out what happens in our points array. I'm hoping to see these values just randomly appear, right, in a random order. And duplicates are okay, right? I can do duplicates. So, okay, how many random points would I like? I'd like 3 of them. And, I mean, okay. This is technically possible, right? It's very much possible for me to randomly pick 1 3 times in a row. Maybe not even that unusual. A little bit unusual. What if I do 25 values? Okay. Right now, I hope this is a clear sign that something is wrong. For me to pick 25 ones in a row, technically possible, but you know, more likely due to a mistake. And if it's not, then we need to go start buying lottery tickets, right? Because we just really are getting lucky. But it's not. It's a mistake. Does anybody see what the mistake is? Yeah.
Is it casting too early, so it just has to zero?
Yes. It has to do with the cast. Order of operations is very important. I'm sure you all learned order of operations, years ago in your algebra classes, but the order of operations you learned probably didn't include casting, right? Because that wasn't a thing that you talked about in algebra class, I'm willing to bet. Well, casting is an operation, and it does have an order, just like every other operation, and it happens before multiplication does. So what that means is that it was taking math.random and casting it to an int right away, which is going to give me what? 0 every time. Math.random gives me a value between 0 and 0.999999999. If I take whatever that value is and I cast it to an int, 0 every time. That's why I was always getting 1, because this was 0, this was 0. What value is it position 0, 0? The 1. No randomness involved yet. But how do we fix this? With our good friend parentheses, right? If we stick some parentheses in here to clarify our operations, then that should hopefully resolve. Oh, I didn't mean to do that. That should hopefully resolve the problem. Let's run this again now and make sure that if I pick 25 values at random, oh, okay, cool. Now that actually looks to be random, right? Random values. See everything represented. Okay, this is the solution. This is a correct solution. I didn't ask this question here, but on the exam that I asked this question, there was actually a follow-up that I kind of want to chat with you about. This is a random sample with replacement, meaning I can randomly select the same thing more than once if I want to. What if I didn't want to? What if I want to do a random sample without replacement? Meaning that once I've randomly selected something, I don't want to randomly select that thing again. Right? I want to eliminate it from any future random selections that may take place. The question is, what would I have to do to make that happen? And I'm looking for an answer not in code, but in English. Can you describe to me what would have to change about this code in order to avoid selecting the same thing more than once? Anybody have any ideas what you would need to do? Yeah.
Could you maybe just like keep track of every data point that like you went to,
Mhm.
and do like an if statement like if it's not that data point?
You're on the right track. Yeah, you're on the right track. A couple things I think you need to be careful of. So you said keep track of all the data points. It's important to be 100% clear what we're keeping track of. The value is actually not what I want to keep track of. Think it's very possible for me to have the 2 show up more than once. And in that case, I would want to be able to pick this 2 and this 2. But I wouldn't want to be able to pick either one of them more than once. So it's not actually the value that I'm trying to avoid duplicating. It's the position that I'm trying to avoid duplicating. So, okay, then back to your idea. We can keep track of what positions we've already visited, right? And then use some kind of structure. I think you said an if statement. You're close with that one. I would think that similar to what we saw on assignment 2, right? There's no guarantee that if I pick a place I've already been to and I try to regenerate it, I might also pick a place that I've already been to again. In fact, there's no limit on how many times I might randomly select a place that I've already been. So not an if statement, but a while loop, I think would be a better fit there. So some kind of a while loop around this that says, while we haven't been to row/column, generate a new row and column, right? That can be done in a couple of different ways, but I think either way that you choose, you need an array. You need another array. You need at least one more array. I'm either going to have an array of integers that allows me to write down all of the row-column pairs that I've picked, right? So that I can make sure not to pick the same row-column pair again. Or my personal favorite solution to this would be to create a 2-dimensional Boolean array called visited or something like that, right? When I visit a particular value, I'll also go to my Boolean array and set that position to be true, meaning I've been there, right? So if I look in this 2-dimensional Boolean array at that position and I see true, that means I've already picked that value. I have to regenerate my row and column and pick another one. If I look in this 2-dimensional Boolean array and I see false, that means I haven't picked that value, so I'll use it and then mark it as true so that I don't use it again in the future. Both answers are fine. I think they're both okay. But either way, you do need another array, and you need to keep track of the positions that you've already been to, not the values, in order to accomplish that. Yeah, awesome. Any questions on this problem before we do some other problems? Yes?
Could you go over how you decided to put it into like the rows for the 1 array that you made versus like in the last problem we ended up putting it in the columns because like I gave her across the column.
Okay.
So I guess just like for each problem, like what would you be thinking about?
Well, in this problem, I would say the rows and the columns don't have an effect at all on what we're doing. I want it to be purely random. Whereas the last problem that we did specifically said that I'm taking the sum of the columns. So to answer your question, it's really just based on what the problem is telling us to do. If I were to use I here instead of J on this problem, it would be wrong. It would just compute the incorrect sum because I am not treating things consistently across the code.
Would that like add across the rows?
Um,
Or would it just be like wrong?
what would it do? Yeah, it would add across the rows instead. Yeah. Mm-hmm. Yeah, I'm glad you're thinking about it like that. That's a good question. Yeah. But it's kind of it's kind of the hardest thing for me to even express or convey in class, right? I'm giving you what are basically word problems, everybody's favorite from math class, and asking you to solve them writing code. So, I'm teaching you what tools you have, but you have to decide how to use those tools appropriately. That's programming, right? I know how for loops work. I, as the programmer, have to decide when to use that for loop, when to use that if statement. Just like, if I'm building a house, I have to decide when to use a regular claw hammer or a sledgehammer. It's my choice based on the task at hand. And if I use the wrong one, I might have a bad time. I might not get to where I'm trying to go. I might make a mistake. I might break something. So that's tricky, but ultimately what I'm hoping for you to get out of this class and for you to show me on the exam. Any other questions on the problem that we just did before we take a look at another one? Any questions? We have time for at least one more, if not two more. It's your last chance to have an influence over what problems I cover today. Otherwise, I'll pick one. Anybody has one? Okay, I'll pick one then. Let me think. Do I want to do more arrays? I feel like people can never get enough of arrays during this review session. Let me think. No. I like this one. Question 1. So for this problem, we are tasked with making what's called an upper triangular array. If you've taken, linear algebra or any kind of matrix arithmetic, then you may have heard of this concept before, but honestly, it doesn't really matter. It's a pretty simple concept to understand. Along the diagonal, every value I want to be a 1, and above the diagonal, every value above, I also want to be a 1. So I want every value on the diagonal and above it to be a 1. Every value that is below the diagonal, I want to be a 0. And since I'm talking about diagonals and triangles, it's important to note that this is a square array. It will always be square, right? I think that's something to also pay attention to on the exam. Sometimes I will say, you can assume that the array is square or something like that. So pay attention to those. Here I'm quite clearly saying it's only effective for square arrays, n by n arrays, right? But it wants us to create these triangular arrays. It wants us to create a brand new array and fill it with these 1s and 0s so that the upper triangle is filled appropriately. So let's take a crack at it. I gave you this starter code. And actually, this is an important point to make as well. If you need the scanner for a problem on the exam, I will give this to you. I will give you the line of scanner code. I might make you write this part. I think that's fair game. I think you've done that enough on studios and stuff to where I don't feel bad making you do this part. I will never, ever, 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 ever ask you to write this on the exam. In fact, I would go one step farther and say you should never, ever, 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 ever write this on an exam. If you need the scanner, I will give you the scanner stuff. If you don't need the scanner on a problem, don't put it in. You're probably just overcomplicating things. It happens. I'm telling you this for a reason because it happens, right? Some people really want to put that scanner into everything. Resist that urge. It's not always necessary. Take a look at the problem. If you need the scanner, I'll give it to you. If you don't need the scanner, I won't, and that's okay. You do not need to put it in. I'd say don't put it in. If you put it in and it's not needed, more often than not, you're going to lose some points on that one, unfortunately. But back to the problem at hand. We're using the scanner here, and it's reading in a value for n, and I need to make this n by n array. So let's go ahead and start with that. It says it wants it initialized to 1.0. I don't know why that's listed as a double. I think int is fine. But if you want to make it as a double, it doesn't matter. It's the same thing. I don't think I counted off either way. for this problem. Int or double is fine for this purpose. It does need to be two-dimensional though, so we are making square arrays here, right? So two-dimensional. I'll call it triangle. It's going to be a new integer array, two-dimensional, and I know it's square. I know I want it to be n by n, so for the size, I'm just going to simply say n by n, right? I want this to be an n by n square array. Okay. Our next task is to fill it with ones and zeros, and actually I'd like to point out that these zeros are already there. Whenever I make a new array of integers, it's already filled with zeros. So there's really kind of two ways to approach this problem. You can pretend like these zeros aren't there and fill the entire array if you want to. That actually might be simpler in some ways. Or if you want to, you can actually write code in such a way that I only visit these spots. I only visit this upper triangle and change these to ones, and I just ignore these positions entirely. Both answers are good, and they're actually not that different from each other. I'm going to try the one where I visit every single spot. So I'm going to visit every single spot and put in either a 0 or a 1 depending on what it needs. And then we can talk about the other solution too, since I think we'll have a little bit of time. Okay, I just said I'm going to visit every single spot. I really hope that when I said that, your brain said, whoop, oh, we're doing a 2D array traversal here, right? I know what he's going to do next. He said we're visiting every spot of this 2D array. You should already know what I'm about to start doing. I'm going to use that nested for loop structure because that's how we visit every spot of a 2D array. So here we can actually kind of take advantage of the fact that we have n. I could say, triangle.length here, and that's not wrong, but I can also just say n, and that's also not wrong, right? And doesn't take me nearly as long to write out. So either way, okay, there is my nested for loop. And now we just have to kind of reason about this a little bit. If I am on the diagonal or above it, I want to do a 1. If I'm below the diagonal, then I need to do a 0. How do I know when I'm on the diagonal? Can somebody help me out with this? How can I tell if I'm on the diagonal or not? Can I use these values of I and j to help me determine when I'm on the diagonal of my square array? What do we think? Yeah.
It's kind of like the line like y equals x. So if you need something like I plus j less than 0, it's like
You're on the right track. You're close. You're warmer. It's even simpler than that though. But I understand what you're saying about the line. Yeah, you're close. This is 0, 0, right? That's top left corner. That's 0, 0. What position is this? 1, 1, and this one is 2, 2. You can see the pattern, right? I'm on the diagonal if I and j are equal. I know I'm on the diagonal if I and j are equal. Okay, how do I know if I'm above the diagonal? I is less than j. If I is less than j, I'm above the diagonal. This is position 1, 2. Where 1 is I and j is 2. So if the row number that I'm on is less than the column number that I'm on, I must be above the diagonal. If the row number that I'm on is greater than the column number that I'm on, I must be below the diagonal, right? Okay, we can actually sort of combine those conditions together. If I'm either on the diagonal or above the diagonal, then I would say that by saying if I is less than or equal to j, if I is less than or equal to j, I must either be on the diagonal or above it, right? Equal means I'm on the diagonal, less than means I'm above the diagonal. In either case, the outcome is the same. I want a 1 there. I want a 1 in that spot. So let's say that. I'm going to go to the array at this position, and I'm going to put a 1 there. Now, I think technically this is it, but I want to look at a few other different possible solutions that people could come up with. I think this is correct. And to understand why, consider that if the opposite is true, I don't really need to do anything. The array is already filled with zeros, so I don't need to do anything. But if you really wanted to make extra, double sure, right? I did see a lot of people say this, if I is greater than j, then the value needs to be 0. Not wrong. Also not necessary. It's redundant. It's not necessarily required, but it doesn't hurt anything. It doesn't hurt anything at all. I think this solution would work. Let's test it out though. In order to test it out, I need to print. I need to print out my triangular array, which again is going to require me to do the nested for loop structure again to do the printing. And I might try to do the printing like this. All right, let's print out my triangular array and see if it actually looks good. Let's just start with the smallish one, 5 by 5, and oh, uh-oh. Okay, are these values right? Are they wrong? Well, they're not really being shown to me properly. Remember that I need to do a little bit of extra work if I want to print out my 2D array so that it looks right. The way that I have it written right now, you'll notice that I'm printing every value on its own line. Well, that's not really what I want. I want the row to go on the same line. We talked about this in class last week, right? This should just be print, not println. I want all the values within the same row to occur on the same line. So I don't want to use println for that. I just want to use print. And then once I get to the end of a row, then I want to use println so that I move down for the next row to be on the next line. So in practice, that means coming down here and putting my println statement in the outer loop, but not the inner loop. So this is the end of the row. Might want to go back and take a look at when I talk about this in class last week if you need a little refresher. But let's try it out and see if we got things looking a little bit better now, hopefully. 5 again. Oh, okay, yeah. They're all kind of all smashed together. If you don't like that, then you can also just come in here and concatenate a space in between your numbers so that kind of spreads them out a little bit. There we go, yeah, that looks nice. I can clearly see my triangle. It's good. This solution works. However, let me illustrate that this is redundant. I can take this out. I can run it again, and it didn't change anything. I got the exact same triangular array back out, right? So I don't need to fill the zeros. And in fact, I can tweak this a little bit more such that I never even go to these spots in the first place. This is maybe the trickiest solution, but also kind of a nice little clean optimized solution. Consider this. Instead of starting j at 0, I don't need to start on the 0th column all the time, right? I just need to start from the diagonal. So on the second row, I don't need j to be here. I need j to start here. On the third row, I don't need j to do these two values. I just need j to start right here. Well, the diagonal, remember, is when I and j are the same. So what I'm saying really is that I need j to start at not 0, but I. And then that allows me to get rid of this if statement, because the way that I have written these loops means that I'm not even going to visit these. I'm only going to visit the upper triangle and fill it in with ones, and I can prove that to you by running this one final time and showing you that it still works exactly the same as my prior solutions. That being said, all three of the solutions that I've shown you, full credit. right? Don't freak out if you didn't get the most optimized, concise, fewest line solution. That's not what I'm looking for. I'm looking for good working solutions. Question?
So just to clarify, like the reason the redundancy was provided basically to the array with a bunch of zeros at its start. But if like say we were provided an array with a bunch of random values.
Yeah. If this didn't create an empty array with a bunch of zeros, then you would need to specify that else statement. You're absolutely correct. Yeah. Yep, we're taking a little bit of advantage of a shortcut here. But yeah, another thing to keep in mind too is that I've only been doing this for 5 by 5, but this should work for any array. So, type in 10, make sure it still works. This is kind of the fun part for me. There's a nice big, or can it do 50? Oh yeah, it can, sure, why not? Right? Like it's a computer, that's nothing. That's not a problem for the computer to do. Write it and make sure it works. It's kind of pretty, I think. Any other questions on this problem? This is a solution right here. Any other questions on this problem? Okay. There are only 4 minutes left. I don't think that's enough for me to go through another one of these review problems, unfortunately. But I will stick around. If you have any questions, you want to come chat to me after class about the exam, be happy to do that. Otherwise, I will see you either in the labs on Wednesday or definitely on Thursday evening at the exam. Have a good rest of your week, everyone.